Friends, I'm having a doubt. How to identify a decimal number is rational or not? Let's try to find out together. For this, do like, share and subscribe the channel. Hi everyone. In last lecture, we learned about real numbers. Now in this video, we learn about rational and irrational numbers in detail. As we know that a rational number can be written in form of p by q, where q is not equals to 0. But irrational numbers cannot be expressed in form of p by q. But what if the number is given in decimal form? In that case, how do we come to know that the given number is rational or irrational without converting it into fractional form? Let's try to understand. Suppose I'm having a number 2.4. So as we can see, there is no any other number after the digit 4. So it's a terminating number. Again, I'm having a number 5.678. Here we can see after the decimal there are only 3 digits, 6, 7 and 8. Again, it is terminating after the digit 8. So we can say this is again a terminating number. Okay. Now, what if a number is like 4.777 and so on? We can write it in short 4.7 bar. As we can see, the digit 7 is repeating itself again and again after the decimal and it is not going to terminate anywhere. So we can say that this number is non-terminating recurring number. Or take one more example, 5.676767. This can be equivalent to 5.67 bar. Here again, you can see 676767 is repeating itself after the decimal and not going to terminate. So we can say that this number is also non-terminating recurring number. So all those numbers that terminate like these are terminating number, and all those numbers those are non-terminating are called non-terminating. And if there is a single digit or a pattern of some digit are recurring, then we can say they are non-terminating but recurring numbers. So all those numbers, those are either terminating or if non-terminating then recurring, are called rational numbers. So we can say there are two conditions to be rational. Either the number should terminate, or if it is not terminating, then it should be non-terminating recurring number. If there is any number which follow either of the two conditions, which fulfill either of the two conditions, it will be rational number. Okay. Now, there could be a possibility that there is a number, let's say 7.876432 and so on. It means the number is not terminating, but we don't know what the next digit would be. So we cannot write in form of bar as we have done in previous questions. So this is non-terminating and also non-recurring number. So we can say all those numbers, those are non-terminating, also non-recurring, are irrational number. For an example, root 2. If you try to find out the value of root 2, it will be something like 1.414 and so on. Means after the last digit 4, what will be the next digit? You don't know unless you find the value of root 2. And you cannot put the bar on any digit as we have done in previous questions. So this is again non-terminating and non-recurring number, and that's why we can say that root 2 is also an irrational number. Same condition goes for root 3, root 5, root 7 and so on. So I hope it is clear what is terminating and non-terminating number, what is recurring and non-recurring number. And on the basis of these, we can divide them into rational or irrational numbers. So let's summarize what we have learned yet. As you can see, what we have learned in this lecture, the rational number is either terminating or non-terminating recurring numbers. We have seen the example. And if it is given in form of fraction, means in form of p by q, then q should not be equals to 0 and p and q should be co-prime integers. What are co-prime integers? Let's take an example, 2 by 3. Here we can see that 3 is not equals to 0. So it's a fractional number. But between 2 and 3, there is no any number common between 2 and 3 other than 1. Like if we find the prime factors of 2, it will be 2 into 1, and prime factors of 3 will be 3 into 1. So there is only 1 which is common in both the numbers. So any pair of number in which there is only one number common, that is 1 only, then they are called co-prime numbers. So 2 and 3 are co-prime numbers. So that's why they are rational numbers as well. Now we have learned about irrational numbers as well. These are non-terminating and non-recurring number. As you can see the example, root 2, root 3, root 5 and even pi. They all are irrational number. That's all for the day.